in this example, we're going to use the same data that we saw in the proportion test and look at the baby data to determine whether or not these training sessions helped to provide better support for the patients. So before these training sessions were initiated for the staff, new mothers were asked to rate the support that they got from the hospital from 1 to 10. And then, that was in January, right? And then we know the hospital initiated these training sessions for their staff. And then after those training sessions were in place, new mothers were asked to rate the support that they received 1 to 10. And what we want to know is, have these new sessions for staff, has it helped to increase the mean rating that these patients are giving the hospital? So we're looking at the mean rating, and again, this data is found in these columns: January support, September support. We already used columns 1 and 2. This was the proportion of mothers who plan to breastfeed. Now we're looking at the rating that this hospital received. January represents before the training sessions were initiated for the staff. September is after. So we're looking at January, and we're going to call that mu1. So I'm going to abbreviate this. I'm going to say mean 1. Right? This represents the before the sessions, the training. I'll write before the training. And this is found in the January column. Mean 2, this is the after the training. And this is found in the September column. And we can find this, right? We have the January support, the September support. January represents the mean, the first mean, and September represents the second mean. So what we want to do is to test whether or not the sessions have helped to increase the mean rating. So if these sessions helped to increase the mean ratings, then mean 1 would be less than mean 2. And that should make sense. If they did, and this is the claim, if the sessions help to increase the mean ratings, we would find that the mean before the training is going to be less than the mean after the training, the mean of the ratings, right? This is the scores that the hospital received. So in this particular case, if we are going to write our null hypothesis, so our null hypothesis and our alternative, we know, since we're dealing with an inequality sign, mean 1 less than mean 2 is going to be alternative. However, the problem is we know that we need to incorporate this in terms of a inequality involving 0. So if we move mean 2 over to this side, this is the same as saying mean 1 minus mean 2 is less than 0. That's going to be important, right? This is going to help us. This is how Minitab looks at the calculations, that the difference is less than 0. The null, we know we just assume that the means are equal. There is no change. That's what null means. There's no change, so we'll assume that they're equal, which means the difference between the two is equal to 0. So again, null, as we've seen before, has an equal to. There's no change. There's no difference between the two means. And if this ends up happening, right, if we end up accepting this, this is evidence that the training hasn't helped, right? If we end up failing to reject the null and there's no difference, this is evidence that training hasn't helped. However, if we reject the null in favor of the alternative, this is suggesting that training has helped. And when I'm saying helped, I'm talking about the ratings, the rating of the hospital. Right? So how are we going to put this information into Minitab? It's actually quite simple. We go into Minitab, we go to Stat, Basic Statistics, and we're doing a 2-sample T. The information is not available in one column. These samples are in different columns. The first column is the January support, right? That's for the first mean. That's where we want to get the mean ratings of the January support. In the second column, we have September support. We are not going to assume equal variances. Do not assume equal variances. When you click on options, let's see if there is a significance level. There is. There's a 0.05 significance level. So that's 95% confidence level. There's no difference. That's never going to change. You're going to keep that 0. And if we go back to the alternative hypothesis has that the difference is less than 0. So we need to change the alternative to less than. After that, you click OK, OK, and you get this printout. We are testing the January support ratings and the September support ratings. We are looking at the difference here. We're testing that the difference is equal to 0 versus less than 0. What we find is that this t-value is negative 7.45. And the p-value, this is our test statistic, and our p-value is essentially 0. So very, very small. So I'm going to copy this, and I'm going to paste this back into the problem. Maybe I'll make this a little larger. So our p-value is equal to essentially 0. Our alpha level, our level of significance, if we go back up here, is 0.05. So the first thing I want to do is to make a claim just based on the null and the alternative hypothesis. The p-value is less than the level of significance. So since the p-value is less than the level of significance, what does that mean? Well, we know if the p-value is low, the null has got to go. So we are going to reject the null hypothesis. So since the p-value is less than the level of significance, there is evidence to suggest, or evidence that we can reject the null hypothesis. This is going to be essential. You need to have at least one statement about just the null and the alternative, but then you need to go back and say what that's suggesting. What is there evidence to suggest? Well, if we are rejecting the null hypothesis, that means there's evidence to support this right here. There's evidence to support the alternative. So there is evidence to suggest that the mean ratings after the training sessions, so the mean ratings after the training sessions, or I guess we should say mean rating after the training sessions, is higher than the mean rating before the training sessions. There's evidence to support the alternative, which is suggesting that the mean rating after the training session is higher than the mean rating before the training sessions. There's evidence to support that and going back up here, has the new sessions, have they helped to increase the mean ratings? There is evidence to support that the sessions have helped to increase the mean ratings. Okay. So first I read the problem. I decided that I want mean 1 to represent the first sample. I wanted mean 2 to represent the second sample. I thought about, well, the claim here is that the sessions have helped. If the sessions have helped, mean 2 is going to have to be, if the sessions have helped, then mean 2 will be larger than mean 1. Which I know that's going to be my alternative, which I have to rewrite in terms of a value and representing mean 1 and mean 2 as a relationship with 0, a difference in 0. So this is my alternative versus the null when they're equal. Before I even calculated anything, I related the null and the alternative hypothesis back to the problem. The null hypothesis was that there's no difference, which means the training hasn't helped. The alternative hypothesis is that mean 2 is larger. That's suggesting that training has helped. I put the information into Minitab, calculated a p-value, and compared that to my level of significance. I made a decision about the null and the alternative, and then I related that back to the problem.